Okay, this is example 4 of solving system of linear equation using technique of elimination. So example 4 is written right here. Now in these two equations, when I compare the coefficients of the 2x and 2y, I realize that the coefficients of the 2x are not the opposite of each other, and the coefficients of the 2y are not the opposite of each other. I also know that the smaller coefficient of the x is not a multiplicative factor of the other coefficient of the x, which is the 5, and the same thing can be said for the coefficients positive 4 and negative 9 of the y's. Okay, so let's just say I want to eliminate the x again, because you know the first two example I already eliminated the y. Since these two equations of the x are not multiplicative factors of each other, how am I going to eliminate the x? By somehow converting one of the x coefficients into a number and the other coefficients into the opposite of that same number. Well, the trick is to come up with the least common multiple of the two equations. The two coefficients of the x variable. Now, if we compare the coefficients 5 and 3, well, we know that the least common multiple of these two are 15. So if I can somehow convert one of these coefficients into 15 and the other one into negative 15, then when I add these two equations, the two new equations vertically, I will be able to eliminate the x variable, and then I can go ahead and proceed to solve for the y. All right. Now let's just say I want to convert the top number into 15. Well, to convert the top coefficient into 15, I just have to multiply the entire first equation by positive 3. Now to convert the second x coefficient into the opposite of positive 15, which is negative 15, since I have positive 3, well, to create negative 15, I just have to multiply the entire second equation by negative 5. Oops. So distribute it in, and something right here. My new top equation would be, let's see, 3 distributing to the 5x is going to be positive 15x. 3 distributing to the positive 4y is going to be positive 12y, equal, well, this is going to be negative 90. 3 times negative 30 is going to be negative 90. My new second equation will be, let's see, negative 5 times positive 3x is going to be negative 15x. Negative 5 times negative 5y is going to be plus 45y, equal negative 5 times negative 18, it will be positive, let's say, 90. But hey, guess what? I can now go ahead and eliminate the x, because looking at these two x variables, their coefficients are the opposite of each other, positive 15 and negative 15. So adding these two equations vertically, the x is going to be multiplying by 0, then plus 57y, equal negative 90 plus 90 is going to be 0. Anything multiplying 0 is just going to be 0. So the left hand side will be left with 57y equals 0. Get y by itself by dividing both sides by 57. I'm left with just y equals 0. But hey, that's going to make our calculation a little easier, because anything multiplying 0 or 0 being divided by anything will be 0. So taking y equals 0 and plug it back into one of these equations to solve for the other variable. So I'm going to plug it into the second one. So take the second equation, plug it back in. I would have 3 times x minus 9 times 0 equal negative 18. Well, anything multiplied 0 is just going to be 0. So we're left with just 3x on the left hand side equal the right-hand side negative 18. Get x by itself by doing the opposite of multiplying positive 3, which is dividing both sides by positive 3. I'm left with just x equal negative 6. So the solution, or the point of intersection in other words, of this system of linear equation is negative 6, 0.